Hello, ladies and gentlemen. Welcome. My name is My-Linh Truong, and I'm the Unmanned Laser Scanning and UAS Business Segment Manager for RIEGL USA. Joining me today is my Austrian colleague, Philipp Amon, who is the Business Division Manager for Unmanned Laser Scanning at RIEGL Laser Measurement Systems. Together, we'll be presenting on RIEGL's UAV-based laser scanning news. Today, Philipp and I will give an update on our new products and newest developments for unmanned laser scanning marketplace. This presentation will provide insight into our new LiDAR sensors, the RIEGL VUX-120 and Minivux-3 UAV, expanding our VUX and Minivux series portfolio respectively. In addition, we would like to showcase a new accessory for the DJI M600 UAV platform, the Integration Kit 300, as well as a few camera integrations to expand your UAV usage capabilities. As an introduction, bringing here with our European legend, this stork, bringing our new baby, the VUX-120 LiDAR sensor. The new VUX-120 is a very powerful and lightweight UAV-based LiDAR sensor, coming in at only 2 kilograms or 4.4 pounds. With a wide field of view of 100 degrees, this scanner is able to cover a large scan strip and features a very unique scanning mechanism we call nadir forward and backward, or NFB scanning. This offers a nadir look angle, a forward 10 degrees look angle, and a negative 10 degrees backward capability to optimize your coverage of vertical structures such as facades or power line poles. With its very high measurement speed of 1.8 megahertz, the VUX-120 offers an extremely high point density capability. This instrument is perfectly suited for the unmanned corridor applications, such as power line mapping, especially integrated onto fixed-wing UAVs. We've prepared a short video to give you a sneak peek of the key features, so let's dive right in. So I'm going to transition this over to my colleague, Philipp, to discuss the details of the VUX-120.
Thank you, My-Linh. I will go ahead here. And before highlighting the key features of the instrument, I would like to give you an overview about this new scanning scheme used by the VUX-120. So the VUX-120 offers a sophisticated scan pattern consisting of scan lines with periodically changing directions. The scan directions in the center of the scan lines change consecutively from nadir to plus 10 degrees forward and to minus 10 degrees backward. This scan pattern provides an almost a complete 3D data set, as also vertical surfaces like the facades of buildings and objects like masts and poles. In addition, the nadir directions enables the reliable data acquisition also in narrow canyons down to the bottom. Because this question was already addressed a few times, I would like also to mention that it's a three-facet mirror where the facets are tilted to each other. Yeah, here once again, so it's a three-facet mirror, three-facet mirror. Facet 0 is pointing in nadir, facet 1 is plus 10 degree, and facet 3 minus 10 degree. Here again, this should also be showcased in video. Again, this is now from another perspective, showcasing it once again, nadir direction, the plus 10 degree forward direction or looking capability, as well as the backward minus 10 degree. So to the key facts or key features of the WUX-120. It's an online waveform processing LiDAR sensor. It's a small companion to the well-established RIEGL WUX-240 scanner, which is already well introduced on the market. It's suitable for the installation of small fixed-wing drones, so this is what it was prepared for, but it can also be used on other platforms like on multi-rotor. It can be operated on flight altitudes up to 720 meters above ground level or 2,350 feet. It's quite small, as you will see later also. And what My-Linh already mentioned, extremely lightweight with only 2 kilo as the single sensor configuration. It's specified as laser class 1, which means eye safe. And with regards to multi-target capability, it can penetrate or we can capture up to 15 targets per laser shot. With regards to the pulse repetition rate, it can be operated up to 1.8 megahertz, enabling up to 1.5 million measurements per second on the ground. It has a wide field of view of 100 degrees, including this NFB scanning scheme, nadir, forward and backward, and offering therefore very high point densities. It supports camera control and timestamping for up to 2 external cameras and has an internal data storage, an internal SSD of 1 terabyte. In addition, it includes a removable CFast memory card of data storage up to 256 gigabyte, which is directly integrated in the instrument, and also provides web interface either by Wi-Fi or by Ethernet connection. And of course, can be integrated with INS GNSS system, like we support with an APX20 UAV system. With regards to the range performance, the pulse repetition rate can be set between 1.8 megahertz, so 1,800 kilohertz, and 150 kilohertz. Using the 1,800 kilohertz program, a measuring range at natural targets at 80% reflectivity of up to 450 meters can be achieved. This means that the maximum operating flight altitude above ground should therefore not be more than 230 meters. In today's regulation on the unmanned sector, in most scenarios, the highest pulse repetition rate, of course, can therefore be used, and to also achieve these point densities or high point densities on the ground. In comparison, using the 150 kilohertz measurement program, also on natural targets on 80% target reflectivity, we can achieve a measuring range up to 1,430 meters, flying at the operating altitude of 720 meters. What can be achieved or what point densities can we get from the sensor? So let's take a closer look here. So taking a typical fixed wing UAV as reference by using a flight speed of 30 knots or 16 meters per second and a flight altitude of 120 meters or 400 feet, a point density of 320 points per square meter can be expected. Of course, we can go more in detail about that later as well, but therefore I would recommend more to get better insight in our reparameter software. Okay, with regards to the system components, we do also offer a full system. So what you see here at, of course, the LiDAR sensor, at the front end, the camera mount, which indicates here an RGB camera. As an example here, it's a Sony a6000 with a 12mm lens. At the back end, it's an interface box providing the electrical board for the APX20 INS GNSS system and the external IMU sensor. So to stick this all together, how the system looks in real, you will see it here on the right bottom corner. We are currently integrating together with Dell AirTech in their DT26X, the VUX-120 system. So it's a company located in France for different coordinate mapping applications. Actually, the integration is currently ongoing, so I do not have some data to share, but as soon as available, we will let you know. To compare, all the sensors together, VUX-240, VUX-120, and also the VUX-1LR series sensor, you will see that the VUX-120 has an accuracy of 10mm and a precision of 5mm compared to 20mm and 50mm accuracy on the VUX-240 side. The maximum measuring range differs. For example, you have a range performance using 1.8 megahertz pulse repetition rate of about 450 meters with the VUX-120 and 700 meters with the VUX-240 by using 150 kilohertz. Offering here range up to 2,150 meters measuring range compared to 1,430 meters on the VUX-120 and even 1,540 on the VUX-1LR with 50 kilohertz. The target echoes are all the same for all the sensors up to 15 targets. And with regard to the wavelengths, the VUX-120 differs in the laser classification, at least from the VUX-240 as laser class 1. The VUX-240 here is specified as laser class 3R and the VUX-1LR also as laser class 1. With regards to the field of view, it's quite a noticeable key feature of the VUX-120. It's a 100-degree field of view compared to 75, but also including this native forward and backward looking capability. And of course, having still the 330-degree or 360-degree with the well-established VUX-1LR. With regards to the weight, it's the lightest sensor here with 2 kilo, the VUX-1LR with 3.75, and then followed by the VUX-240 with 4.1 kilogram. On the data storage side, all offering the internal SSD drive of up to 1 terabyte. And in addition, the VUX-120 also offers a removable CFast card, which is already available in the single scanner configuration. And the line speed here can also be used up to 400 lines per second on the VUX-240 and VUX-120, whereas the VUX-1LR is only able to achieve 200 lines per second. So if we now compare especially the VUX-240 versus the VUX-120, you will see there's a significant weight difference, comparing 4.1 kilo and 2 kilo on the single scanner weight. If you integrate all this together with an Aplanix APX20 as an example, you will end up at 4.9 kilo on the VUX-240 side and 2.9 kilo on the VUX-120 side. So still, there's a significant 2 kilo difference. With regards to the camera options, what's being offered, or at least what's available, as I mentioned earlier, we can operate or control up to 2 external cameras. At the front end, the direct camera mounting payload capacity is limited to 700 grams. And in this case, we can either make use of a Sony Alpha 7R with 36 megapixel with a 21 millimeter size lens covering a 81-degree field of view, or as another example, a Sony Alpha 6000 camera with 24 megapixel with a 12mm lens. Of course, the lens also can be exchanged, offering here 89-degree field of view. Of course, also other models are supported, like mentioned here, the Sony a7R III, or what we're currently integrating, the Sony a7R IV, or also phase 1 cameras, like the EXM50/100. But in this case, we need to make use of some customized payload mounting options, where we talk with the end client a little bit more in detail about how we can mount all this together. It all is stable and also stabilized on the mounting platform. Yeah, we do have some very first data to show. Honestly, it's just a few screenshots here, but it should showcase what at least can be achieved. So this is really only a sneak preview of some WUX-120 data. Some parameters here, it was a single pass operating at 140 meters above ground with a speed of 12 meters per second. Was flown with a multi-rotor system, providing us around 550 to 600 points per square meter. It will end up in this configuration with a SWOS with around 330 meters. So if we take a look on the data, or at least on this NFB scanning scheme, you will see here three colors. First, if I do it step by step, nadir here in gray, then the forward was plus 10 degree and minus 10 degree backward looking capability, all end up in one big data file, but this is actually how the data can be combined. We're currently working on some demo data for the WUX-120, so please feel free to leave your email or to give us a call or an email later on that we can also share these data sets with you. And now I will hand over again to My-Linh, which gives you a little bit more detail about the Minivux-3 UAV.
Thank you, Philip. Next, we would be pleased to showcase our expansion to the Minivux product line, the new Minivux-3 UAV. The Minivux-3 UAV is a lightweight ULS scanner coming in at 1.55 kilograms, or about 3.4 pounds. But the unique feature about the Minivux-3 UAV is offering up to 300 kilohertz laser pulse repetition rate with a scan speed of 100 lines per second. This sensor is an expansion of RIEGL's miniaturized UAV product family to increase the overall performance, to meet our specific demands for UAV application, and in line with the Minivux series, the 3 UAV offers a new color design, but do want to make clear that this sensor is not a replacement for the well-established Minivux-1 UAV or Minivux-2 UAV, which we launched last year. This sensor is simply an expansion overall to this product family. Offering the user-selectable 300 kilohertz, 200 kilohertz, and 100 kilohertz, this sensor has a unique feature by offering triple the laser frequency compared to the Minivux-1. And this offers the ability to fly 3 times faster than you're able to with the Minivux-1 UAV, capturing the same point density on the ground. Or you can fly at the same speed as before, but tripling the overall point density, which provides a more feature-rich point cloud for your data analytics. The main difference between the scanners is that the field of view for the Minivux-3 UAV does get reduced and limited by using the higher frequencies. A 120-degree field of view would be available by using the 300 kilohertz laser pulse repetition rate, which means that the laser is only really recording in the 120 degrees down towards the ground, which in most cases is enough for your application. With the 200 kilohertz, that field of view is increased a little bit more to 180 degrees. And of course, the 100 kilohertz is at the well-established 360-degree field of view as the Minivux-1 UAV and 2 UAV showcase. By comparing the Minivux series since its introduction with the Minivux-1 in 2016, you can see that the laser pulse repetition rate for all of these have increased over time. But the Minivux-3 UAV still offers the same accuracy precision as with its predecessors, but the measurement range does depend a little bit on the used measurement program. You can see it's nearly consistent across the board, but there are some flexibilities, and that benefit is showcased here as still to date the Minivux series overall is our lightest weight sensor offering for our UAV product line, which offers a very cost-effective survey-grade accuracy lightweight UAV solution that meets your application needs, which can be dependent depending on your application of choice for data capture. Should you need an increased overall point resolution on the ground or needing a higher laser pulse repetition rate to be able to capture data faster. So let's investigate this a little bit further with a data acquisition example. Flying at 4 meters per second, or approximately 9 miles an hour, and operating the UAV at 50 meters above ground. This offers an average of 240 points per square meter with one flight pass. And another example showcased here, flying faster at 6 meters per second, or 13.5 miles an hour, and operating the UAV at 90 meters above ground. This yields an average of 90 points per square meter. And again, this is with one flight pass. So this provides quite a bit of range in the overall resolution from the same sensor. Expanding with our Integration Kit 300 for the new introduction of DJI's the M300 RTK UAV. This smaller and lighter weight UAV offers the ability of flying a few of our Minivux systems. The Integration Kit 300 is very similar to our offering of the Integration Kit 600 for the M600 Pro. The Integration Kit 300 still will come with the adapters and mounting plate, your vibration shock absorbers, the new AV14 GNSS antenna. Of course, all the cables antenna mount will interface directly to that. But the key difference is that due to the limited payload capacity of the M300, only a few of our system configurations can be mounted onto it. And so which case the Minivux system integrated with the Aplanix APX20 IMU GNSS at 2 kilograms is supported, or integrating the Minivux system with the lighter weight Aplanix APX15, then the payload will accommodate the integration of a nadir camera, such as the A6000 from Sony, with a payload weight of 2.5 kilograms. Then this is also easily supported onto this smaller UAV airframe. So what kind of flight times can you find with this system integration? With the Minivux integrated with the APX20, we're looking at maximum 34 minutes of airtime. And with the lighter weight IMU, but also the camera at 2.5 kilograms, we're looking at just slightly less time in the air, coming in at max 32 minutes. So still quite a bit of acquisition that can be flown. And with the performance of the Minivux-3 UAV, quite a bit of coverage can be captured. With cameras, as you may be aware, we offer a few different cameras. I just mentioned the Sony A6000, which is a 24.3 megapixel camera. With the Minivux series, we offer a nadir or a dual oblique mount to offer the wider field of view of the Minivux for data colorization. We also offer the A7R3, which is a 42 megapixel camera. In this case, we offer only in a nadir configuration, showcased here, registered with the VUX-1 UAV or LR. In addition, with the Phase 1 IXM 50 or IXM 100 as showcased here. With our VUX-240, we integrate it with a 28 millimeter lens to fit the field of view for the VUX-240. And last but certainly not least, we also offer a thermal camera, which is quite powerful for corridor mapping applications. In this case, showcased here is the FLIR Tau 2 And given its small footprint, it can also be offered in conjunction with the RGB camera options that I just mentioned here. But new to the Sony line is the A7R4. It's a 64 megapixel camera with a variety of lenses that we offer, which we can then combine RGB, thermal, and multispectral. And the multispectral capability is in conjunction with our partnership with AgroWing. They offer a lens. In this case, for the A6000, this special 2 lenses offers 4 bands, with each lens offering 10 megapixels. And for the A7R multispectral camera lens, this is at 12 bands with 4 lenses, which equates to 8 megapixels per band. So how do the images look like when paired together? For our multispectral, you can see that here, and there it is with the A7R and the 4 lenses. So to conclude our entire product line here, on the very small end, we have our Minivux series, the Minivux-1 UAV, 2 UAV, and new Minivux-3 UAV. For optimized corridor mapping applications, we also have our downward-looking Minivux-1 DL, and increasing the capabilities of our VUX product line, the VUX 120 coming in at 2 kilograms, bridging the gap, our very well established VUX 1 UAV and the VUX 1 LR has been established in the marketplace since 2014. Next, increasing in flight altitude, our VUX 240, and last but certainly not least, our VQ 840G for topobathymetric applications.
And I would like to jump in here once again before we stop with this webinar to showcase you also this new sensor live. As you have seen it in the presentation already, but to really showcase you here as the single sensor. Actually, of course, it's a mock-up sensor, but VUX 120, as shown on the images in the presentation. What you will see here in the back is the interface box, once again, to this highlight this multi-purpose connector, which we also make use on all the other sensors, these 2 camera ports, as well as a debugging interface. Yeah, quite nice and quite lightweight instrument. And yeah, looking forward to send you all some data. And I would like to hand over to My-Linh again for the last poll here.
Thank you, Philip. So last but certainly not least, our final poll question: which of these LiDAR sensors do you see the most potential for your business? Our new VUX 120, the new Minivux-3 UAV, our existing VUX series product line where you're not quite sure, same for the Minivux series, or in general, you're still investigating for your UAV LiDAR. And it looks like an overwhelming amount is very interested in the new VUX 120, so that's fantastic news. And that also makes sense given our first poll question is 48% of you is already operating or is interested in operating a fixed wing UAV. So the VUX 120 is perfectly suited for that. Philip, you need to get going on that sample data set so we can share it with everyone and get this off the ground. And thank you so much for your attention today. As you can see here, this is the contact information for myself and for Philip. So if you have any questions that are not answered in today's session, please feel free to reach out to us directly. And let's see what kind of questions that we've received in the meantime.
Perhaps I jump into, because as it was introduced last week at INTERGEO, and we got this question quite often, I would like to step once again into this new scanning scheme, or also how the mirror works. And as I mentioned already earlier, very quickly, it's a 3-facet mirror, so it's not 3 physical laser diodes. It's one wheel, so one mirror wheel, but these mirror facets are tilted to each other in a few degrees. and therefore we do get this specialized scanning scheme with this native forward-backward looking capability. And I would like to just highlight this once again because it was questioned a few times. So would like to make this clear.
Again, if you have any further questions, please feel free to reach out to Philip or myself directly at the email shown here. We will be releasing the webinar recording the first week of November, as we do with all of our webinars each month. So thank you again, and until next time, over and out.